Hi guys, in this video I'm gonna talk about Peering Fabric overview. What is Peering Fabric? Peering Fabric is the latest Cisco architecture and technology of your internet gateway. Yes, your border router that plays very important role among your network, your internet, and your cloud. Cisco Peering Fabric is highly scalable and distributed, very secure as well as agile with automation capability, so that you can provide better SLA and performance to your internet and cloud user. This video is part of Cisco Peering Fabric demo series, and my name is Hinwato. I am a Cisco Technical Solution Architect, a CCDE, and a CCIE. You can get more information of Peering Fabric Network Automation. Just please sign up to ciscolive.com and access to this Cisco Live session, Intelligent Peering Fabric Network Automation Use Cases. There are complete slide deck and demonstration video.
So let's take a look briefly on the Peering Fabric network design. It's based on the Cisco router. It has the automation capability. It really relies on the segment routing latest technology, the segment routing policy, how to steer the traffic in very granular and flexible way, and also on the best practice of the peering technology here in terms of the telemetry, security, and control plane. And all of these operations are working with the iOS XR. So let's take a look at the architecture point of view. Initially, the internet gateway will grow in the vertical manner. We have a big chassis and start adding more line card there. And to add more redundancy, we may add up another chassis here, the horizontal scale, but with the modular and chassis router. And the latest architecture is we can start with the spine and leaf architecture. Then we can start using a compact platform here, even like 1 or 2 RU, and we build with the spine and leaf topology architecture. This distributed model has a lot of benefits in terms of the cost, in terms of the scalability, and in terms of the performance here. So normally the internet gateway start based on the integrated model here. You can see here we use the term PF, Peering Fabric node. So we have this side connection to the peers, the CDN, and the other side connections to the SP or backbone network. And then once it grows, we have the option to build the distributed spine and leaf architecture. The PFL, the Peering Fabric leaf, is used for the peer termination here, and the PFS will act as a peering. Will interconnect with the SP backbone. In this distributed architecture, we have a very large scalability compared to the chassis or big router scale. Here we just add up more PFL to have more access, connectivity to the more peer links, and to add more backbone bandwidth, we simply add another Peering Fabric spine. It's just like a spine and leaf architecture, but for internet gateway network. And in terms of the control plane design, within the spine and leaf, we use the IGP, either ISS or SPF, and we activate LLDP, BFD, and segment routing here. And then specifically for the peering access, we will also use the EPE, Egress Peering Engineering, to have the BGP peering seat here. And here, for the gateway, for the subscriber gateway or the customer service gateway here, we will act as a PFL that later also connect to our peering fabric to the ISIS or OSPF with segment routing. And we also have another network automation software solution and analytic later. So for the ingress and egress traffic policy, here are the options. Here I'm going to demonstrate for the ingress traffic policy based on the AS path length prepend policy to influence the peer route selection. For the outgoing or egress traffic, I will demonstrate how segment routing policy and EPE can help to steer the traffic up to the peer link selection. Here's a bit information on the EPE. So once the BGP peering sheet already established and assigned by this router, this BGP peering sheet can be part of the SR policy here, 5001. So the traffic comes from this router. It will go to the 16001, which is this internet border gateway. And later, if we select the specific peer link 5001, this orange links, not the other two blue links here. So this is how very simple from the source traffic engineering to select which peer link we want to use. This technology has not been there with the current legacy RSVPTE or policy-based routing. Is very complicated now. And also for the incoming traffic engineering, here we can leverage the on-demand Nexthop plus the SR-PCE path computation element to steer the traffic based on the lowest latency. Here in this case, any traffic towards the subscriber prefix from this internet gateway, and then this internet gateway will establish the SR policy automatically to leverage the SR-PCE information and then establish the automatic on-demand SR policy low latency path to this customer prefix. This is a very brief overview for the SR-ODN and SR-PCE. Feel free to check on my YouTube channel. I have a video demonstrating this technology in details. And another peering fabric security, the Cisco Internet Gateway has the security features such as the IOSXR, RPL, BMP, RPKI, NetFlow, flow spec capability, and also it can work with the model-driven telemetry. And we have also the solution cooperate with the Arbor for the DDoS detection and mitigation solution. For the network automation software solution, I will demonstrate the Cisco NSO here, as well as the Cisco Telemetry using the OpenStack platform. We have other automation software here. We can provide the automation starting from day 0, 1, and day 2. In this demonstration, I will focus on the day 2 configuration changes for the peering traffic control, automated gateway policy motion, resiliency with prioritization, and telemetry-based control. What is Cisco NSO? is a network service orchestrator. It is the automation software that can automate the end-to-end service across multiple network elements from physical, virtual, or even the network application. Here, it can help on the create service, update, and even delete service across the multi-vendor and across with the data modeling, young data modeling. Here I will use the REST API to the NSO and also the web UI. For the telemetry solution step, I will demonstrate based on the open source platform, a do-it-yourself way. Cisco has another automation software with the key Cisco Crosswalk platform here. Here are the telemetry OpenStack platform software. It's based on the open source, pipeline, InfluxDB, and Grafana with the capacitor. And this telemetry open source platform will work together with the NSO. It will trigger the input for the NSO to do the network changes on the internet gateway. The streaming telemetry has the advantage the router can send the network statistics proactively in up to the per second to the telemetry collector here, the pipeline. It's different approach from the SNMP, which is pull, and the telemetry is a push approach. Okay, this Jack Wells quotation, I think, is very good. Control your own destiny or someone else will. In our case, control your own multi-cloud and peering traffic or something or someone else will. That's from the Peering Fabric network automation. So this is the additional peering resources you can revert to. Please take a look. It's very good document, very well documented, and very a lot of resource. I love this all blogs and the segment routing resource. Very good books from Clarence and Chris, which are segment routing books part 1 and 2. Looking forward to part 3 for the SR-PCE, as I know. And yes, please check my YouTube channel as well. I have recorded some segment routing use cases as well as with the segment routing policy or part computation element and SO in terms of the transport and VPN service and architecture of transport as well. I think later I will add more video recorded there. And also the segment routing channel on the YouTube. Yeah, that's very good. I think, hope you get very useful this session. Thank you. Feel free to reach me for any update or for any concern. Thank you very much.